Vercel just released a new programming language called Zero, and supposedly what makes this one different is that it's been built from the ground up so that humans and AI agents can ship small native programs together. But isn't this what we've all been doing anyways? So what makes this one better? And is it actually a good idea, or is it just another side project that nobody's going to be talking about in a few months? Let's find out. So Zero is a systems language like Rust or Zig, so maybe something that Bun can rewrite to one day. And as far as I can tell, the whole idea is that current languages were built for humans. So we read the error messages, the warnings, and the traces, but AI works much better when it has structured data. So with Zero, the entire toolchain has been built with that in mind, meaning that everything the compiler produces can be output as JSON. Now, just based on those points alone, and the pretty obviously AI written sentences on this website, I'm still pretty skeptical on why this exists and how well it's going to work, but I'll save my opinions for the end. First, let's just explore the language itself, because, I mean, it is still pretty cool. We'll start with the classic I'm learning a new language project, printing out a very simple string. Most of this is pretty easy to understand. We have a public main function as the entry point to this program. This function is going to return void, and inside of here, we're printing out a string. But it's the way that string is being printed that points out our first few features. We are using the world capability. You need this capability if you're doing any I/O operations, like file operations, printing, network calls, any I/O side effect. And it's all part of the explicit principle of this language. If a function has this world capability, it's an immediate signal that it does some I/O operations, and if it doesn't have it, it means it's going to be I/O side effect free. The world capability also allows the compiler to reject unavailable capabilities based on the target at compile time instead of runtime. So if you try to use file system access within this function and then try to target a WebAssembly build, the compiler would error out first, so you're not going to be surprised by a runtime error later down the line. After the world capability, in this program we also have some keywords. So we have check here, which is how you handle errors. If a function is able to fail, you mark it with raises, and then check here is used to propagate that error. It's pretty similar to Rust's question mark operator, but just as a keyword. So that's everything we need to know for our first program within Zero, and we can run this now by doing zero run and hello.zero. Note this is the file extension for the Zero language. If I hit enter on this now, you can see it says hello, subscribe to BetterStack, something you should definitely do. Moving on from our hello program though, since we're clearly all Zero experts now, the language does have a few more primitives to keep you covered for your basic applications. So I made a new one here, which is just a random app that will classify whether the input is text, numeric, or mixed. And you can see that this uses some features like standard libraries that we have. We have enums in here, we have shapes, pretty similar to structs. Then we have the usual language features you'd expect, like if statements. We have a while statement down here. You can also use for loops. Then we also have match down here, which is pretty much like your switch statement. So nothing too unexpected or new. When it comes to more advanced concepts like memory, again with Zero, everything should be explicit. So we have mutable spans for our writable views, and there's also spans for readable views. And down here we have an owned type. This essentially says that this value is owned here, and when it goes outside of scope, run the drop function. We define the drop function ourselves on the shape here, so this is where we would put our cleanup logic. Another way you can do this is by using the defer keyword and then putting a function here. Essentially what this means is when this function is done and it goes out of scope, run this function afterwards. So it's basically got everything you need for a very basic application today, and there is a few more features, but I don't really want this to be a programming tutorial, but do feel free to put that you have 3 minutes of Zero experience on your CV. With all of that out of the way then, let's focus on what I think is the real pitch for Zero, and that is its toolchain, and the fact that it's been built for AI agents. Imagine an AI agent writes some Zero code and it introduces some bugs. Well, they claim that in most languages, you're just going to get back a wall of text, and those error messages are designed for humans to read. In Zero, you can actually get the human readable one, and it's going to look something like this, but you can see that's not a structured output. So they've made sure that in every part of the toolchain, it actually has a JSON option. So if we run that same function again, but this time using the JSON option, and I'm also piping this to JQ just so it looks a little bit nicer, you can see we get back a nice structured output error message. We have diagnostics here, like the severity, the code, and the message. We have where the error is occurring, its expected value, and its actual value. Then we have some help for the actual LLM itself, as well as a fixed safety field, which says this is going to require human review, and then some information about how this can be repaired. So it's just trying to give enough context to the LLM so it can fix it itself. Another command that shows that off well is the zero fix one. This one I'm using with plan mode as well as JSON, and also piping it to JQ just so it looks nice in our terminal. When I hit enter on this, it essentially does a diagnostic on the classify broken file that I gave it, and it essentially says, what do I need to do to actually fix this file? you can see we get a structured output back with fields that pretty much only an LLM needs to know, like safety levels, the mode, applies edit. We have things down here like self-host repair policy. We then have the diagnostic section, which is pretty much the same thing that we saw in that zero check command. And down here, we also have the fix for that error code itself. So how is this typically fixed? Essentially, part of the idea seems to be, what if the language provided its own documentation when it was needed? So if we pointed an LLM at this new language, it wouldn't really need to look up any documentation or use any skills. It would just be able to get enough information from the toolchain when it's actually needed. So to put that to the test, I put our broken file in a brand new directory that has no information on what the zero language is. And now I'll simply ask Claude to fix that broken file and also give it the command that it needs for those diagnostics, because it does need some information on how to actually use the toolchain. With that, we can go ahead and see if Claude can actually fix this file. Well, there we go. After 31 seconds, it's managed to fix all of the errors in the file, and I actually introduced 3 of them, and it's found all 3 and fixed them, and we can scroll up and see how it's done it. It is simply just running that zero fix command that I gave it. This time we got back OK true, so that's how it knows there is no errors left. And if we scroll up, we can see that it made some code changes, and it did that because in the previous step, it ran zero fix and got some information on how exactly to fix that issue, and it did that with all 3 of the issues that we had. So this had no prior information on what the zero language is. It didn't use any web search or anything like that to fetch the documentation. It simply used the information that the toolchain provided as structured outputs. I'm actually a little impressed by that. This is a brand new language that an LLM can still debug thanks to how the language has been built. But there is one thing I'm left wondering. Is this really new? I mean, I get the whole selling point of errors and everything in the toolchain having structured outputs, but that's not really a new concept. We've had structured error messages for decades. I mean, look at this. I have roughly the same classify program built in Rust, and it has similar errors, and I can just ask for the output to be in JSON. I'm not really sure that we needed a whole language to be built around this idea, and maybe you could have just improved the existing ones if you thought there was a gap in the information. I'm also pretty sure that if I took that broken Rust code and asked Claude to fix it, it would be able to do so with ease, and that would be even if it wasn't using structured outputs. I feel like LLMs do a perfectly okay job with normal messages, or maybe I just haven't run into that issue. On top of that, we have the fact that LLMs have been trained on loads of existing coding languages like Rust, so it's going to be pretty good at debugging that, and it has lots of examples in its training data, but with Zero, it has absolutely none. Now, that doesn't mean you should never try and add in a new language. It just means if you're building a complex app, you wouldn't reach for Zero, but to be honest with you, they're not really marketing it as that anyways. Overall, I think this is just a neat experiment, and if anything, it does show that you can still build a new language and give LLMs required context without having them be trained on that language. But I'm just not really sure if this was needed. None of that is to say that the language itself isn't cool. As I said, it's actually not that bad to use, and it does compile down to a nice size. I just doubt that I'm ever going to use this over established ones like Rust, Zig, or Go. I'm sure there's going to be lots of opinions on this one, so let me know what you think in the comments down below. While you're there, subscribe, and as always, see you in the next one.